Hey everybody, this lesson is called Problem Solving Using Exponents. Alright, so here we go. We have a bunch, sorry, hit the table with my hand. You have a bunny rabbit, and for your birthday you get another bunny. Oh boy. Every day the number of bunnies you have doubles. So create a T-chart. Alright, so let's go ahead and create a T-chart. So I have days over here, so each day and the number of bunnies. Okay, so on the first day, we're going to put right here, we have two bunnies because that's on your birthday right here. And then it says it doubles every day. So on the second day, we're going to double that. And then on the third day, we're going to double that. And then on the fourth day, we're going to double that. Okay, so on the first day, we have two bunnies. So double is 4, double is 8, double is 16. Okay, those are happy bunnies, aren't they? All right, so this next part is going to say graph that equation. So let me move it up there. So let's go ahead and graph that. Okay, now I'm thinking, how am I going to cover all these numbers? 2, 4, 8. See, if I did by ones, 1, 2, 3, I can't even get to that 8 right there. What if I did by twos? 2, 4, 6, 8. I can get the 8. The 16, I'd have to extend that up. Let's do them by fours. This will be 4, and then this will be 8. Okay, you guys follow me right there? So I did it by fours right there, and I did the x-axis by 1. So 1, 2, 3, 4 right there. Okay, well, now let's go ahead and graph that. So I'm going to go over 1 up 2. So over 1 up 2, that's half of 4, so that's going to be like right about there. Okay, I think I highlighted that in red. Yeah, I did. Okay, so we did 1 comma 2. Okay, now let's go over 2 up 4 right there. Okay, so over 2 up 4. All right, so over 2 up 4. Well, 4 is this line right here. Okay, now we're going to go over 3 up 8. So here's 3 over here, and then we're going to go up 8. It's going to be right about there. Okay, so I'll make that one my red dot right there. And then watch this. When I go over 4 up 16, it's going to be way up here. Okay, now, what if we did this, you guys? What if we said, hey, what about 5? What if I went up 5? Okay, well, I just double this again. If I double 16, then it's going to go way up to 32 up there. So I'd have to extend this baby way up to 32 and then keep marking it and make sure these spaces are correct. And then what happens is exponential graphs always makes this kind of, and they call it almost a J curve. It almost makes a J curve right there. So there's the exponential graph. If I did 6, you guys, it would be up there at 64. It would be up off the page right there. Okay, so there's that right there. And then the next part is going to say write an equation to model this. Well, they keep doubling. So look at all these numbers right here. Here's 2, here's 4, here's 8, here's 16. Well, you might not see it, you guys, but look at this. This is 2 to the first. This is 2 to the second. 2 squared is 4. 2 to the third. 2 times 2 times 2. 2 times 2 is 4. Then times 2 is 8. This is 2 to the fourth. Look, it's 2 to this power over here. 2 to the fourth is 16. 2 to the fifth is 32. Okay, so the equation is going to be y equals 2 to the x, and x will be whatever your day is right here. So how many days right there? So now that we know that equation right there, let's use this to predict how many bunnies there will be after 10 days. Okay, it's going to be 2 to the 10th. I do know that. And then so I got to start thinking, okay, 2 to the first is 2, 2 to the second, and if I kept doing that, you guys, so here's 2 to the second is 4, 2 to the third is 8. I just keep doubling it, you guys. So double that is 16, double is 32. That's 2 to the fifth, 2 to the sixth, double it. 2 to the seventh, double that. Double that is 256, so that's 2 to the 8th, 2 to the ninth, double it again, 2 to the 10th, there it is right there. So after 10 days, if those bunnies kept having babies and babies and babies, and I know what you're thinking, how can bunny babies have babies and all that stuff, but this is a math class. This isn't about, real life. We're actually doing math problems here. And so actually bacteria and stuff, bacteria doubles like this all the time. So it does happen a lot in other things, but definitely not bunnies. But wouldn't that be a lot of bunnies running around your backyard? 1,024 bunnies? Ooh. Okay, anyways, so now let's try another one, you guys. We have 3 marbles, okay? And every day the number of marbles that you have triples. Okay, so I'm going to create a T-chart. Okay, so here's the number of days and the number of marbles right here. Okay, so I'm going to go day 1, day 2, day 3, day 4. So it says you have 3 marbles. So that's going to be on my first day, 3 right there. Okay, and then it says it triples every time, so that means times 3. So on the next day, on the second day, it's going to be 9. Okay, on the third day, it's going to be 27. Okay, I just multiplied it by 3 because it keeps tripling. 9 times 3 is 27. 27 times 3, you guys know what that is? It's 81. Okay, and then it's going to ask us here to go ahead and graph that. So I'm going to go over 1 up 3. So let's go ahead and put a chart in here right there. All right, so now I got to think about, I'm definitely not going to graph this for 81. I don't have enough room to go up 81 unless I did, like, counted them by 20s or something. Well, if I counted them by 20s, this would be hard to recognize. 1 comma 3, even 2 comma 9 would be kind of hard to recognize. So I'm just going to graph these first 3 right here, and I'm going to go up by 4s again. Okay, and I extended it up so I can get that 27 right there, and I went up by 4. So 4 plus 4 is 8, plus 4 is 12, plus 4 plus 4 plus 4. 28 is way up there, so when I graph 27, it's going to be a little bit down. Okay, so let's graph 1 comma 3 over 1 up 3. Okay, it's not quite up to 4, so it's right there at 3. So now I'm going to go over 2 up 9. Okay, over 2 up 9, so it's a little bit past 8. Now I'm going to go over 3 up 27. Okay, that's going to be way up here, not quite to 28, but almost to 28, okay? All right, can you see that kind of tall, skinny J curve right there? If I graph those right there, exponential graphs always graph these, and these are called exponentials because, let me help you with this here. It's because when it says write an equation of this, this is y equals 3 to the x. Look, here's 3 to the first power. 9 is 3 to the second power. 27 is 3 to the third power. 81 would be 3 to the fourth power, okay? So these are called exponential graphs because our variable is in the exponent position, okay? And probably you haven't seen this stuff yet. So predict how many marbles you'll have after 30 days. All right, well, it's going to be 3 to the 30th, you guys. Well, 3 to the 30th is so big. You guys, I would not want to punish you with that. You can just leave it as 3 to the 30th. I plugged that into my graphing calculator. I teach AP statistics and AP calculus, you guys, and I plugged it into my graphing calculator, and it gave me a number that looked like this, 2.06 with an E. This E means the exponent to the 14, and all that means is that decimal goes to the right 14 places. So if it went 14 places, it's going to be 206 trillion. A trillion is 9 zeros. So 206 followed by 9 zeros. That's a huge number. You wouldn't even have room to keep all those marbles in there. All right, I hope that lesson makes sense, you guys. Take care.